Welcome to the mesmerizing universe of stars. Have you ever gazed up at the night sky and wondered about the life of the brilliant points of light overhead? In this video, we will explore the incredible life cycle of stars, how they form, evolve, and in some cases meet spectacular ends as supernovae. From the dense clouds of interstellar gas that cradle their births to the explosive deaths that spread elements across the cosmos, the story of stars is one of creation, transformation, and rebirth. Buckle up as we embark on this cosmic journey. Our story begins in a molecular cloud, a region filled with gas and dust in space. These clouds are often called stellar nurseries because they are where new stars begin to form. Over time, regions within these clouds collapse due to their own gravity, leading to the formation of a protostar. As the material gathers, the protostar starts to heat up, and eventually pressure builds in its core. When temperatures reach around 10 million degrees Celsius, nuclear fusion ignites, marking the official birth of a star. This process converts hydrogen into helium, generating immense energy that causes the star to shine brightly. Once a star has ignited nuclear fusion, it enters the main sequence stage of its life. This is the longest phase in a star's life cycle, lasting billions of years. During this time, stars like our own sun stabilize, balancing the gravitational forces pulling inward with the outward pressure from nuclear fusion. Main sequence stars vary widely in size, temperature, and spectral type, from red dwarfs, the smallest and coolest stars, to blue giants, characterized by their massive size and extreme heat. The Sun is classified as a G-type main sequence star, G-dwarf, spending about 10 billion years in this phase before moving towards its next stage. As stars exhaust their hydrogen fuel, they begin to undergo significant changes. For stars like the Sun, once the hydrogen in the core is depleted, the core contracts under gravity while the outer layers expand, transforming the star into a red giant. During this phase, the star's exterior cools, giving it a reddish hue. The increased pressure and temperature in the core allow for the fusion of helium into heavier elements, such as carbon and oxygen. Our Sun would eventually expand into a red giant, engulfing the inner planets, possibly including Earth. However, this process is several billion years away. The destiny of a star depends on its mass. After a red giant runs out of fuel, it can take one of two paths. Low to intermediate mass stars, like the Sun. As the star loses its outer layers, they drift into space, creating a beautiful planetary nebula. The core left behind becomes a dense remnant known as a white dwarf, which will gradually cool and fade over time. Massive stars. In contrast, when a massive star exhausts its nuclear fuel, it experiences a rapid collapse followed by a dramatic explosion known as a supernova. A supernova can outshine entire galaxies and is responsible for creating many of the elements found on Earth, such as iron and gold, through nuclear fusion. These elements are then scattered across the universe, seeding new stars and planets. After a supernova, what remains can become one of two incredibly dense objects: neutron stars. If the core left behind is between 1.4 and 3 solar masses, it collapses into a neutron star, where protons and electrons combine to form neutrons. These celestial objects are incredibly small, typically about the size of a city but with a mass greater than that of the Sun. A sugar cube-sized amount of neutron star material would weigh as much as an entire mountain. Black holes. If the remaining core exceeds 3 solar masses, it collapses beyond the neutron star stage into a black hole. The gravitational pull of a black hole is so strong that nothing, not even light, can escape its grasp. This phenomenon is not only fascinating but also raises profound questions about the nature of the universe. Dramatic fact: the boundary surrounding a black hole is known as the event horizon. Crossing it means an object can never return. This notion of gravity and space-time warping challenges our understanding of physics, leading to groundbreaking theories in modern astrophysics. The life cycle of stars is not merely a process of birth and death. It's a continuous contribution to the cosmos. Elements formed during these cosmic events have played a crucial role in the formation of planets, including Earth, and the emergence of life. Nearly every atom in your body was formed in the heart of a star. Carbon, oxygen, nitrogen, and other elements necessary for life were crafted in the stellar furnaces and distributed across the universe through supernova explosions, seeding new generations of stars and planetary systems. Our own Sun is a third-generation star, formed from dust and gas enriched by previous supernovae. This means that the elements that compose us have traveled through space for billions of years, highlighting the interconnectedness of all matter in the universe. Today, scientists continue to study the life cycles of stars using advanced telescopes and technologies, helping us unlock the mysteries of the universe. Projects like the James Webb Space Telescope and other observatories around the world are enhancing our ability to observe distant star systems, measure their properties, and understand their life cycles. Dramatic insight. These missions aim to answer profound questions about the universe, such as how stars form, evolve, and ultimately contribute to the cosmic environment we observe today. Observations of distant supernovae help astrophysicists to understand dark energy and the expansion of the universe, showing that the quest for knowledge is ongoing. In conclusion, the life cycle of stars, marked by birth, transformation, and death, serves as a remarkable reminder of the dynamic nature of our universe. From the formation of the first stars after the Big Bang, to the vibrant celestial spectacles we see today, the journey of stars is one of resilience and continuity. Thank you for joining us on this stellar exploration. If you found this journey through the cosmos enlightening, please like, comment, and subscribe for more captivating dives into the wonders of our universe. What aspect of the life cycle of stars fascinates you the most? We're excited to hear your thoughts in the comments below.